Have you ever felt overwhelmed by complexity of structuring class while building new feature? Or have you ever wondered how senior engineers effortlessly organize their code, write maintainable, scalable code? Well, then you need to learn about design patterns. Welcome to the series. I'm Subendu Vart. I've been working as a professional Laravel developer for over 8 years now. In this series, where we'll reveal about design patterns for Laravel developers. So let's first understand what are design patterns exactly. So they are a tried and tested solution for common problems that arise in day-to-day life of developer while building new feature or organizing code and things like that. So these solutions are well tested by over the years. So these solutions also help us whenever the common pattern arises while building any features. All right. So why we need to learn about design pattern? So first is, of course, we need to write a code that is maintainable. If we keep on adding new features, the code shouldn't break, and our code should be understood by all developer, and it should be testable. Another is communication. So while communicating with other developer, if you say that let's implement a strategy pattern while solving for this feature, then everyone will understand. So you don't need to explain like you need to put class here and this pattern. Another one is so now in age of AI era where you need to vibe code or you need to build some feature using some pattern, you can just say to AI implement this is using this feature. You'll get more accurate response when you have the vocabulary of true programmer. All right. So another thing is to promote yourself from junior to senior level, meaning think in terms of solution, not just writing code. How should it be written efficiently so that it can be scaled. All right, so these are well enough reason to learn design patterns. Now let me explain what we will cover in this series. So this is specifically for Laravel developers. We will what problems or what kind of patterns we face while building Laravel web application. Well, now let's talk about course content, what we'll cover in this series. So first one is we'll learn about solid principle, quick overview, because all these design patterns are based on solid principle. They apply solid principle via these patterns. We'll learn about how Laravel service container helps us implementing these pattern and where Laravel itself uses those kind of patterns. We'll also discuss about types, all kinds of design patterns, and we'll only discuss about patterns that are most useful and most practical for developing any Laravel web application. So these types of design patterns are categorized into creational, structural, behavioral. So these are to create some object, and these patterns are to structure our classes and to determine the behavior, to write the algorithm for different kind of logic. We have behavioral pattern. So we'll discuss about 2-3 patterns in each category that are most practical for our Laravel web application, and then we'll also discuss about a Laravel architectural pattern. So these will help us to how we should organize code, when to use service classes, action classes, how to implement these patterns, where to put our code and things like that. And finally we'll learn about how to efficiently choose the pattern out of all these patterns, when to use which pattern, and when not to over engineer the feature or over engineer the solution, when simple solution can be enough. Using these design pattern might be overkill. So we'll learn about all these. After completing this course, you should be quite confident on creating any kind of scalable feature that you'll be proud of, and you will be start thinking in terms of in terms of solution like a senior Laravel developer. All right, let's start learning about design patterns with our first step, which is understanding solid principle. Because all these design patterns are based on solid, they try to implement solid via these kind of patterns. Let's see first this order controller. What do you think about this controller? So the store method of this controller contains validation logic, creating order, processing order items, updating the inventory, a lot of things happening inside single controller, right? So while starting, you might have written this kind of code. I have written this kind of code. It's totally fine if there is only this controller and we are only the purpose of that application is just to store the order. That's it. But that is not the case with most of the e-commerce or any kind of application. We need to keep adding new features and keep changing all these implementation, how the inventory should be updated. So after updating, we need to send emails, things like that. So this is the common example where which is violating all of our solid principle. All right. So let's first quickly. So if you already know, just come along with the ride. I will just give you a quick refresher of solid. So most important most important principle out of this solid is S, which says that single responsibility. What this means is one class should do only one thing. Let's say this class controller is a class, right? So this controller class should only do one thing, but right now it is doing a lot of things. It is creating order, validating, all of stuff, right? So let's first go through all of these and then we'll see how we can use these principles in that messy code. O means open closed. What this open closed means, any class should be closed for modification and open for extension. What do you mean by that? More meaningful example, more practical example is example of any packages that you use in your Laravel application. The classes or the code, the feature or any functionality in that feature is closed for modification. You cannot go to vendor and modify anything and then make it work. But that package is extensible. We have some way to extend the feature that package is already giving us, whether it is by injecting our implementation via service container, or by extending the class via service container again, or changing from config. So there are a lot of ways that we can extend the functionality. We can put our new class in a config variable or change any config. You get the idea, right? So that is O in open close principle. So any class, once you return that class, you should write that class in such a way that you can extend, but don't someone shouldn't go there and make any changes that that invites chances of breaking the existing feature. All right, third principle is least-scope substitution principle. So what this says is consistency among your classes. What do I mean by that? Let me explain with example. So here I will paste some classes. Just ignore the code above. So here I have so these will be on separate class, of course, but here I have put this in one single file, easier to understand. So let's say we have an interface we have feature of payment processing. We have an interface where we have to process payment, which can be processed via Stripe, via PayPal, and things like that. There might be other, right? So what least-scope substitution principle says that in your subclass or class which implements your interface, there shouldn't be any other feature which is different than what parent says. All right, so let's say it is accepting one parameter, and you create one class, and then you change it to something like some other parameter, amount, type, although you put default by type, something like this. So now this is the class which implements payment process, but if you look at this, it doesn't have, it only accepts one parameter, but you have made it so that it accepts two parameter. So it is kind of in gray area whether you should follow these or not, but following that principle helps, because someone already faced some problem using these, and then they come up with those principles, right? So that is another one, L. So what I says is create a small interfaces instead of one big interfaces where there are 5 methods, and in class which implements that interface do not use or only use three methods from that interface, but do not use another 2. That you shouldn't do. All right, you should create, instead you should create 2 separate interfaces and use whatever makes sense for the class. All right, so that is interface segregation. And D is dependency inversion, meaning instead of depending on concrete class, you should code in such a way that you should be dependent on interfaces, because when you use interfaces, you can swap the implementation. All right, so these two kind of confusing. If you are new, you can just ask for example for these two, although we'll discuss about these in detail in our upcoming series, where we'll discuss about upcoming videos where we'll discuss about all these design patterns. So just for now I will skip those, but these are the foundation for all those design patterns. All right, let me give you a quick tour of how service container works. What are the essential methods that we'll need while learning about design patterns. Let's see this example. So whenever we inject some class via constructor, Laravel service container will inject this class and it's all dependencies of this class for us. All right, so there are 2 ways to create classes, right? Let's see. Here you can create new class using this new keyword, or you can directly inject into your controller's constructor. So whenever you inject like this in controller, the service container injects this class. In this case, this is the simple creating new class, no service container. That's one thing. So what are the advantages of using service container? So Laravel in many places it already uses service containers dependency injection like this. You might have seen the request class getting injected. So behind the scenes, a lot of services are used to get us all the request variable that is all hidden behind the scenes. So this is one example of dependency injection. So I highly recommend you read this documentation. So another thing that we need to know about these binding basics. So there is one way to bind class. Let's say you can do like this, app bound. Let's go into app service provider. So in this provider, let's say you want to bind some class to something. You can use via this app, using app, and this app, same thing, bind, and here you have like Stripe. So in your controller you might be using this payment contract instead of Stripe payment service, which is example of dependency inversion in Solid. So you should always use this contract class wherever you need the functionality related to payment gateway and anything, whether it can be in controller, routes, anywhere, and you come to this app service provider and just bind whatever you need. Let's say in future you don't want to use Stripe, you want to use like PayPal, then you can just come here and swap this with PayPal service class. All right, so you don't need to change anywhere in code, just come here, change it, just implement that contract, everything will be good to go. So this is the powerful feature of. So another one is this singleton. So we'll learn about this singleton pattern in a bit. So this is just a way to tell Laravel that we only need one instance, do not new of this class every time you resolve. So using this will create new instance of this class every time we need it. Using singleton instead, we'll only create one once whenever we call this. All right, this is the difference. And last one I want to talk about is another method, instance. So how different is this instance is, let's copy this example. Let's say we have like this. So we already have one service, we new up that service using traditional object creation and then pass in whatever we need, and then using Laravel service container we bind this class to already existing service class or already existing object. So we need, when you have existing object that you want to bind, you will use instance method, otherwise you just use bind and singleton most of the cases. So just know these methods exist. We will use this in our upcoming videos where we explain about other topics. So I think that is it about service container. If you know these concepts, that's it. So types of design pattern, I will call it DP in short. All right, so these are broad category of design patterns. All right, there are different creational patterns that are useful, very useful, that Laravel already use them. One is factory pattern, singleton, and third we have builder pattern. All right, so first let's jump into factory pattern. So again, take example of this payment gateway, and we have, let's say, different strategies. We have this class, let's say we have this class like payment gateway factory, and there is a static method called create, and we will pass it some string here, and out of this string it will resolve, it will create any class. So remember single responsibility principle. This class, the only responsibility of this class is to create new payment gateway object. How it will do is it will accept this, and then if it is Stripe, then it will give us a Stripe, and otherwise this. All right, a factory create, that's it, and we'll provide which object we want to create, Stripe, and we'll use this class. All right, so this is the factory pattern. Example of singleton pattern. Let's say you are using some third-party API, whether it can be OpenAI, Google APIs, Google Calendar, whatever. So in that class you need API client, API secrets or anything, and you are simulating any you are doing any expensive service. So in case of Google Calendar, that might be initializing a new project for you, or any embeddings or anything that needs some computation while initializing that class. All right, in that case you don't want to instantiate that class as many times as you need that. Let's say you need this class from your controller, from any other service class, or in your command class, wherever you need this. You don't want to create a new instance of this class every time you need that class. So in order to have only one instance throughout your application, you will achieve that via singleton method. How do we do that? So here in service provider, inside register method, we will call singleton, and whenever someone needs that class, let's say third party. So let's say we need third party API client, and what we'll do is we'll instantiate it with all our secret key and whatever configuration needed here, and it will have only one instance. Let's say let's go to our code and let's create some instance of this class. Let's say client1 resolve some third party client, resolve some third party API client. By the way, this is same as calling app, which will help us resolve that class from service container. And so when you call this first time, it will call this class and create a new instance with all the config variable, and whenever you call it second time, it won't new up this time. It will return same instance that has been created while doing this. So another one is builder pattern. So you might have already seen in Laravel query builder, if you are building any complex object where different steps are needed, let's say you do where, you do get, you might do take few items, all right, take 5, or do order by something, or you can do latest. You get the idea. So whenever you feel need while creating object, you need multiple steps or multiple configurations while creating that object, you use this builder pattern. All right. Okay, now that we know what is builder pattern, let's learn how to implement this pattern. Let me give you a simple example of let's say we have this simple report that we are creating. We have this simple report class where a report needs to be generated with title, content, and footer. There might be a few other configuration. Let's take this as an example, and you can implement a report interface and make sure that this method is mandatory. Right now, to make it simple, we will not implement any interface for now, but remember there is interface which got this generate method. Now in order to build this, we will use another class called report builder. All right, so that report builder class will help us build this report step by step, like we built the query object. So how do we do that? We will define another class. This is our report class, this is our report builder class. All right, so this builder class will also implement some interface just to make sure that these methods exist. So for now I will skip this implements interface. Just remember these are the methods in report builder interface. And so let's take a look at each method. So in order to build report, we need to have title. All right, so how title will be constructed? Set title, we will provide title, and then we will assign that title to this property, and then return this. So this is important. So after you return this, you can chain another method in this class, because this class is report builder itself, right? And you can call another method when you use this. And similarly, you can set footer and set content, and then finally you have build method. So this method will actually build the simple report class with all these titles. So the work of these method is just to get the data from user, so that it can build this class by providing all the constructor parameter, which is simple class instantiation with all these parameters. All right, and how you use this? So wherever you need to build report, you will first create a, let's say you use this builder and instantiate first the new class of report builder, and then you will do, we will say, let's say report builder build. You can just simply say report builder build and it will build. But before building that, what we need to do, we need to provide all the information like set title, and similarly, and whenever you call this method, it will set this to this parameter and then return this, and then you call this, and finally you will call the build method, which will create our simple report. So this is the report object. So this is the how simply you can build a builder. Alright, so this is all about creational design patterns. Alright, let's learn about structural design pattern. So by name, it is clear that they add structure to the class. What their work is to assemble object and classes into larger structure while keeping them flexible and efficient. What does that mean? So they do not create anything, they do not change behavior of anything, unlike creational and behavioral design pattern. So the example of structural design pattern are facade pattern, adapter, decorator, and repository. So these four pattern will be going to discuss. So first one, facade pattern. So let's learn by example. Here let's say I am doing user registration, and there are a lot of services involved in user registration. The registration of user is complex for your system. Let's assume that. So while user registers, what we need to do is we need to validate their tax requirement, subscription, we need to email them, so we need to initialize multi-tenancy system for them as well. So these are complex steps that needs to be done. So individual service classes are handling those. So each service class contains all the complex logic for each of these steps. And in these kind of system, the facade pattern help us to assemble all these service classes into one places. And what we just need to do is we just need to call this register method on user registration facade. So wouldn't this be cool? Just call register and everything will be handled behind the scenes. If your requirement is this complex, where several service classes, several other logics are involved, and you need to assemble them into one places, then facade pattern is right choice for you. So in Laravel also we have facade classes. So if you see those classes, they help us to easily call any other methods without initializing in static syntax like structure. You can call different kind of facades in Laravel, whether it is auth facade. Using auth facade, you can call a lot of methods like login using ID, things like that. All right, so the work of facade is just that. Next, let's learn about adapter pattern. So the adapter pattern acts as a bridge between two incompatible interfaces. Let's learn by example. Let's say in our application we have already implemented a weather service, right? So that weather service we are already using from provider 1. Let's say provider 1 which provides us weather data. We have already implemented 2-3 providers, and in our application we have this interface where we are using this get current temperature and get current condition, and we are using this on any dashboard page or anywhere. And now there is a requirement that we need to integrate, we need to use a new weather provider which is really cool in market, which provides really good data and whatever the reason might be. So in order to integrate that external weather API in our system, let's say external weather API has this kind of interfaces. Let's say we are using their SDK. So most of the external service provider provide us SDK to easily integrate their service in our application. So their SDK has this interface. It provides data like this into single object like this, which returns temperature and condition. But in our application we already have these two separate methods, and we are used to call these two specific methods. But when we use this, it is not compatible with our application code, right? So what to do? Create a adapter class which will make this class compatible with our already existing weather provider. So let me write code how we'll do that. We should create a new class. Let's say class, this will implement of course weather provider and contains all the methods that are required. So I will quickly add this. So now we have this weather API adapter class where we will be using, so in constructor we will accept our external weather API, all right, external weather API which is incompatible, and using, so whatever we'll use now external weather API. So we'll use external weather API and fetch current location data and do whatever we need from these method, these SDK to get our data. You get the idea, right? So this is how we do. Now we have this API adapter class ready. What we'll do, we'll not use this class. What we'll instead do is whenever we need weather API, so this is the interface, right? So now we can bind this class instead of this class from service container. Let's see, what do I mean? Let's go to app service provider. All right, so here we'll bind weather API provider. Whenever someone calls weather API provider, what we'll do is we'll return our new weather API adapter class, and what we'll do, we will pass in our new external weather API which is incompatible into this adapter class. So this class accepts this as a constructor, and it will call that incompatible method and just get our required data. Maybe we will get like this, temperature C, and for condition there is, it returns array and condition like this. You got the idea, right? Now let's go back to service provider. So what we did here, we instead of incompatible class we used adapter. The adapter makes this class compatible by implementing these two methods and using our external weather API that we want to integrate and get us the right data required for temperature and condition. So this is all about adapter pattern. So whenever you find some class is incompatible with already existing feature, instead of adding new feature there and making any change on existing SDK or things like that, what you can do is you can easily create a new class, new adapter class, and pass in that incompatible class into adapter and make it compatible. Now let's learn about decorator pattern. So it is similar to adapter pattern. So only thing that we do in decorator pattern is just like in real life, decorating means adding something on existing feature or existing thing to make it a little bit more better enhanced. So in decorator what we do is we wrap existing class into a new class like we do in adapter. So the work of adapter is to make it compatible with the interface, whereas in decoration we don't worry about any compatibility, we just add some feature and then return it. So decorator is kind of simpler than adapter in terms of implementation. Let me show you one real use case example which will help us to understand really quickly. So let's say we have some repository to make query things like product repository, okay, and we have let's say we have a eloquent product repository, and here we have all these methods which perform perform all the queries that we required using eloquent. And there maybe you might be using MongoDB and other services to make these kind of query. That is just example. Now what you want to do is in this eloquent repository you want to add functionality of caching, all right, to make things little bit faster. So one option is to come in this repository, wrap everything inside this using cast facade, cast remember, things like that. Okay. But that is not ideal, because that violates open close principle on solid. So instead of changing our existing class, what we have to do is we have to create a new decorator class which will add caching functionality on top of this repository. So let me show you how we do that. So we have, let's say we will create new class called class cast product repository, which will of course implement this product repository, and we will have all the methods that are required for product repository to work, of course. And in constructor we will require our original class that we want to decorate, which is Eloquent product repository. So I will use property promotion latest feature. Now here we can do whatever we want, alright, because this is already compatible with Eloquent product repository, whether you use this or this, same thing. So if you use this, there is additional functionality of caching on top of this, and here you can implement all the features that you require. You got the idea, right? So it will return all the, I will not do all the implementation, which will take time. Alright, so now that this decorated class is ready, how do we use it? So Laravel service container to the rescue, app service provider, again we'll go there, and here let's say we already have this logic there. We are binding product repository to Eloquent product repository. So this is the interface, and this is the concrete class that we are using. And now how to use that decorated class without affecting anything? So to do that, we have a extend method. So we have extend method in our service container, which help us to extend this repository by decorating with our newly created cast product repository decorator. All right, and we pass in this repository, or if you want anything to pass in, you can do it here. You get the idea. Now we have control over here, and we are extending our product repository with this our decorated. So if in future we no longer require this decoration, we just remove this and everything works as expected. So the question might arise, why to extend? What if we can directly use this cast product repository here instead of extending like this? So you can do that. If your application requires cast product repository, you want cast version, you can do that. But what this makes it easy is to so if in future you want to use separate decoration, you can just change it here without affecting our original implementation. And it also makes it easy to test this original implementation and this decorated version separately when it comes to unit test. So this all comes to your requirement. So if your requirement is like this, you need to decorate, then you reach out for this kind of solution. Just keep in mind that this kind of solution also exists. Now last, let's talk about repository pattern. So repository pattern is very simple. We already covered repository pattern in this example. Let's say we have this repository and we want to use Eloquent, and if in future we want to use MongoDB or any NoSQL database or any other graph database, that we can use that in our repository. We can create another repository, let's say NoSQL product repository, and implement all these methods and go to our app service provider, and instead of using our Eloquent product repository, we can use NoSQL product repository. So that is the repository pattern. So repository, we will put all our database related query there. If in future we need to change implementation like we just did, it comes quite handy. So in most of the cases you will not require it, because Eloquent itself is quite robust, and it already got everything. So just keep in mind that if that is the requirement in future, or if that is the case in your application, this is the solution for that particular problem, repository pattern. So this concludes our structural design pattern. These are 4 core design patterns that will be useful while building Laravel web application. Let's talk about behavioral design pattern. So these patterns are those kind of pattern which concern with algorithms and assignment of responsibilities between objects. Let's learn this by example. So before that, let's explore how many types of behavioral design patterns are there. So one is strategy pattern, perhaps most useful pattern, and we have state pattern, observer. Obviously we are familiar with observer design pattern in Laravel. We have command pattern, mostly used in our queue jobs, artisan commands. We have template method pattern, which is another mostly used pattern. And finally we will discuss about chain of responsibility pattern. Let's start with strategy pattern. Let's say we are building file exporter. Main method that is required by all kind of file exporter is export. So this is how we define interface, and there can be different kind of file exporter depending on type of files. Let's say there is CSV file exporter, there is PDF file exporter. We have written a CSV exporter like this, and we have JSON exporter. So there may be other implementation like this. So in strategy pattern, our problem is we have to write different kind of algorithm to achieve a single problem. In this case, we want to write file exporter. The main function is export the file, and there can be requirement according to business logic for CSV file, for JSON file, for other kind of file. For that we create one class per strategy or per algorithm. The strategy to export the CSV file may be different. Similarly for JSON it might be different. So all logic will go inside these class, individual class, and during runtime we will decide which algorithm to use according to file type. So if we get CSV file, when user wants to export as CSV, they will click export as CSV. Then we need to decide, we need to hook in this class. So let's say we have another service, report service, which is using all these strategy, and in report service we have we accept file exporter, our interface, and whenever we call generate report, it should export in proper file format. All right, so this is the client that is using our these strategy. And remember, we didn't pass CSV exporter or JSON exporter explicitly, we passed in interface. So this is what I meant by solid D in the solid, dependency inversion principle, meaning now we are not using concrete implementation, instead we are using this file exporter interface, and now during runtime we can swap the implementation. Whichever file exporter we want, we can hook in using our Laravel service container. Let's see how to do that. So this is our setup till now. We have all these strategy for file export, and we have a class that is using that file exporter, and whenever we need to generate report, it will export the data. That's it. So now there are a couple of ways to decide which exporter to use. Right now this function doesn't know which exporter to use, and depending on external input we will decide that. Alright, one simple way, let's say we are using that in our controller or route. We accept some request input format. By default we put it CSV, and we have written one match statement. According to format, it will initialize the respective exporter. So if there are other, we will list down like this. For JSON, we are initializing this class, and by default CSV. Alright, now what we can do is we can simply call exporter export. That's it. Alright, so let's talk about another method. So this method of using this is totally fine, but we are not using this report service class. So this controller is responsible for deciding which class to utilize. It kind of violates some principle of solid. So instead what we can do is we can use a service container to inject, to bind proper exporter class whenever someone wants to call file exporter. Alright, so how do we do that? For that we need to go to app service provider or any provider we have, and what we'll do is I will put that code there. Let's get rid of everything. Alright, so let's see side by side. So what we have done in this new method is, instead of defining this logic here, we put that logic over to our service provider, where we are accepting, basically we are doing same thing. So whenever file export is needed, we will check this logic and then initialize necessary class according to the format. So now what we can do is we can simply let me comment out this and create new methods just so that you can see side by side. Now what we can do is we can directly inject a report service, and we can call report service generate report like this. So now this is being resolved from service container, and we have already defined on service container what to do. There we go. And when you call generate report method, it will automatically check the request object and give us proper class that is needed for the format. Alright, that's strategy pattern. Let's talk about state design pattern. Let's understand this by example. Suppose we have e-commerce website where we have to process order, where we have to ship order, cancel payment, things like that. Alright, and we design that by order state. Let's say we have this kind of order state in our application. We have to process our order, ship or cancel it. So these are different stages of order completion life cycle. We define an interface in each stage. In each state, what could happen? Let's say one stage can be pending state, and then after pending we have processing state, and there can be other state as well. Let's say someone ordered something, it will first go in pending state, then processing, then completed or cancelled. Let's make it simple for now. And in each state we have three functions to perform. One is process. Process means just move ahead, ship or cancel. So in each stage we can perform these three basic actions. So we create the interface for these three actions. And in pending state, what if someone hit process or say process, if order is in pending state and we want to process it, what will happen? It will move this state to next state. Let me format this a bit. So whenever someone hits process, or let's imagine there is an admin panel where someone needs to click on process, and whenever he does that, according to whatever state the order is in, these action will be initialized and these function will be called depending on state. So it is similar to strategy pattern that we discussed. The only difference is this method knows about next state. How? Here it is. So whenever someone says let's process this order and the current order is in pending state, then we are moving this to processing state. So we are assuming that this is the life cycle. First order will go into pending, then processing, then maybe shipped. So depending on your business logic, there may be stages completed, or it can be cancelled in every stage. But let's say these are the state. Alright, there are different state, and for each state we need to perform these three actions, whether we go ahead, we ship, or cancel. So in this stage, whenever we call process, what should happen? It should go to next. Alright, it should go to next. Whenever we again call process, go to next, go to next. And whenever we hit process on the last stage, it shouldn't happen anything, right? It should just ship the project, and when someone hit process, it should show like this order has been already completed. So similarly, you can see how we are writing logic for each stage. So design pattern sometimes can be complex. So if the solution, if the problem is very simple, you don't need to make these three class and do everything. You can do using simple loop if condition. If order state is pending, then do this, else, if else. So the simple solution will be using the switch statement or if else in single method. That is one way. Other way is to create class. So if there is many things happening on each stage, then this is the scalable solution. Let's say we are using all these state in this class, order class. It can be any service class or model class. So what will we do in order class? We will accept pending state. For now we are making this default, and there is a setter, set state, which will set any state that we provide, and then we have these functions. Alright, so this is the context class, meaning this class will use all those states and perform necessary action. Let's say we are using this on our route or controller, which is the final place where we will use this. How do we use that? We will first new up order. Let's create order, create new order object, and we say order process order, and similarly we can say order ship order. So we just need to call this method, and what will happen? Let's go step by step. So whenever first we call process order, what will happen? By default the order will be on pending state. Alright, so whenever we call this method process order, so by default we get the pending state. The state object is now pending state. Whenever we call process, we are calling it on pending state process. Alright, so what will happen in pending state? We are setting state like this. It is setting the next stage. So by default we have pending, and we are setting our next class to set state. And now next time when we call process, we call one time, we got pending state, and then again we call it. Next time we have processing state. Process method of this processing state will get called. So just take a look at these example, you will understand. So it is a little bit hard to understand. So if this is not the requirement for your project, we can totally skip that. So this is just implementation. I will put this code on GitHub. so you can study and make sense of it. All right, next, observer pattern. So we'll not dive deep into this observer pattern code because we already know observer, listener, and event listener we already have in Laravel that follows the observer pattern. So whenever any event happens, whether it is creating order, and there needs to be some actions that needs to be performed, which we perform using our event listeners. So when is the right time to use observer pattern is when some action needs to be happen that are not tightly coupled with that logic, meaning the things like sending email, making some cleanups that you can do on separate queue job, and things like that can be performed using this observer pattern. And next we have command pattern, which is let's say you create any artisan command and we create a separate class for that command, and all the specific actions that needs to be performed in that class we put that on command class. All right, so in that command class what we can do, we can queue that command, or we can just offload that logic to some other process, whether we can run that on cron job, we can run on queue, or we can run that on side. All right, so that is command pattern. So we create a action class that is also kind of command pattern. So nowadays that action class is getting popular, where we put specific logic associated with some particular action, and that we call via that class. So that is command pattern. So another important pattern is template method pattern. It will be kind of useful. Let's dive into an example of this template pattern. Okay, let's say we have requirement to write a data exporter, and we have one export function, and we need to fetch data, format data, prepare something, save it, and then log something. So these are the actions that needs to be performed while exporting some data. All right, and we have those methods as an abstract method defined here like this, and all the default functionality we can write on this abstract class. And now the time to write our data exporter ourselves, whether you are developing package or building some customizable solution for business, then you have created this abstract class. Now you allow client to write their own implementation of data exporter. For example, you can export data from your Apple Notes, from Obsidian, Notion. So however implementation you want to want to write. Let's say let's call this Notion exporter, and the way to fetch data in Notion is different than in Obsidian or in Apple Notes. All right, so you write that specific logic in that particular class, and the formatting step might be different. You write that, and similarly saving is also different. So all the abstract method that you implement in child class or subclass, and you don't need to worry about this export. This export is already written in our parent class. We can just call export method, and all the steps that needs to be performed has been already written on our parent class. So we only write the step specific in that particular class on our new class. Similarly for Obsidian, the fetching step might be different, formatting and saving. So you got the idea. All right, so whenever next time you face this kind of solution where in your implementation some steps are different than other implementation, then you can use template pattern. And finally, chain of responsibility pattern. Let me give you example in Laravel ecosystem how chain of responsibility pattern is being used. So the example of middleware. So if you see in web middleware or in any middleware, these are the default middleware that are being applied. So in Laravel, I think 10 or 11 upwards, it is inside app bootstrap file, which is hidden. But in your previous version, you can find that on HTTP kernel class. Let's say this middleware we have defined, and it will perform some action. It will check for cores. It will validate post size, trim string. So one by one, these steps are getting executed, and in middleware what we call next closure after each middleware. So what that will do is that this performs the step specific in that middleware, and then it creates the environment for next middleware that can chain into that middleware. All right, the middleware system in Laravel is already implementing chain of responsibility pattern. And another example which makes more sense is this pipeline method, where you can call one method after another like this. So this is closure based example. You can just simply write closure and then call this next method. So in this pipeline, what we are doing is we are passing this user object through these three steps one by one. After this step is performed, then we perform this step, and then finally we are returning user object. And similarly here we can write on single class as well, all those strategies. We are sending users, generating profile photo, and then activating subscription, and then sending welcome email. So one after another, so chain of responsibility. All right, so these steps, whenever some steps are performed in certain particular order, you can use this pipeline send and use that. All right, so if you are curious how this has been applied in Laravel, how it actually works, you can visit pipeline class inside vendor Laravel. So at this location, here we have this pipeline class which works like this. So whenever we call send method, we can say it sends the passable and assign this to this property. Similarly, when you call through method and pass the array of classes, it will assign all those to this pipes method. All right, and once all has been assigned, when we finally call then method, then all these data will be used. How it is being used, let's see. Then method, here we go. So in then method, we can see we are using array reduce and reversing the pipes, and then passing all these methods. So what this is actually doing is it is calling one function and passing that function inside another function, so that it calls the next method on that function. So this is how it is being worked. So you can study this class and get to know more about the chain of responsibility pattern. All right, so finally let's review all of our design pattern and learn when to use which pattern. So first, let's talk about creational pattern. These are kind of simple whenever you need to create some object and the process of creating that object is kind of complex. Then you can opt in for one of these method, and if there are multiple steps involved, you can choose builder method. Otherwise, if you are integrating third-party API and there is expensive method being called while initializing that object, you can opt for Singleton Pattern. You will only need that class, one instance of that class. You can use that, and you can call factory method if the strategies there are different algorithm to solve one problem, and the logic to resolve all those algorithm is kind of difficult or complex. Then you can use factory pattern. So factory pattern can work in combination with strategy pattern that we studied. So in strategy pattern, we have different strategy to accomplish one task, and to choose that strategy, if that logic is difficult, then you can choose the factory pattern. Let's move on to structural pattern. And the facade pattern, you can choose that if you are interacting with the different subsystem, like we have talked about in example of user registration, and you don't need to remember which method to call, and you want to have only one method, and everything, all the complexity will hide inside that register method, then you can opt for facade pattern. And adapter pattern, quite simple. It is kind of simple to decide, because whenever you are integrating any contract that is not compatible with your application code and you want to make that compatible, then you will create an adapter class and wrap that incompatible class into your adapter and make it compatible. Similarly, decorator, if you don't want to change the original class and just want to put some advanced feature over just on top of that, like advanced login, logging and things like that, you can use decorator. Repository pattern, just we talk about it. If you are thinking of replacing your database layer, or if you want to use MongoDB, you want to use SQL, NoSQL database together, then you can swap the implementation using repository pattern. And finally, talking about behavioral pattern, strategy pattern, if you have multiple ways to do one particular task, there are different, the example may be payment provider, you can use PayPal, Stripe, any other service. Similarly, importing feature, there can be different strategy to perform one particular solution. Then that way, in that case, you can use strategy pattern. State pattern, if in each state of the life cycle, let's say there are 5 state of one particular event, then each state got different logic, difficult logic to perform. In that case, you opt for state pattern. And observer pattern, if there are loosely coupled logic that you don't want to put on, mostly you'll use observer while you are developing some package or something that you want some external user to hook in particular things at particular lifecycle event. Let's say whenever something created, then you say that just register your listener to this event because this event is getting fired, and things like that. And in command pattern, you will use mostly them for single action that you want to perform, which got the logic, complex logic, and you want only one action, and all that class is about that particular action. This is kind of command pattern. And similarly, template method pattern, you will reach out for this particular pattern whenever there are different ways to perform tasks similar to this strategy pattern, but there is not much difference. There is only some difference, like the way of fetching is different. The data, like we see on our exporter example, in our Notion, there may be different method for fetching and Obsidian, and when you are writing exporter, then particular action in that whole strategy. So the main method is same, but the method, the way to achieve some task is different. Then you reach out for template pattern. And chain of responsibility pattern, you can go out for this when you have sequence of tasks that needs to be performed in that particular object, that particular order. Then you can go out for chain of responsibility pattern. Alright, so this is all about design patterns. Hope you learned something out of this video. Let me know on comment section. I'll see you on another video. Bye.